In this lecture video, I'm going to go over practice exercise 13 from our chemical kinetics chapter. The question states, the first step of a mechanism involving the reaction of bromine is, we have an equilibrium between Br2 gas and 2Br gas. We're told this is fast equilibrium. I know it's fast because the word fast is written here. I know it's equilibrium because I have an arrow in the forward direction and an arrow in the reverse. And a K1 for the forward, a K minus 1 for the reverse. The question states, what is the expression relating the concentration of Br gas to that of Br2? So this is asking for us to come up with an algebraic expression where Br equals another term. This is going over what we learned to isolate the intermediate from a fast equilibrium step. I know this is fast equilibrium. Remember, our definition of equilibrium is rate forward equals rate reverse. Well, my forward rate equals, remember that's this direction, that blue, how I drew that blue arrow, which is K1 times Br2. The rate of the reverse reaction, which is in this direction, so 2 Brs reacting to make Br2, is going to be equal to K minus 1 times whatever's at the tail end of the arrow, right? That's our Br squared. And the reason I can write these rate laws just by looking at this reaction is because we're told this is in a mechanism. Remember, within a mechanism, every step is elementary. And that means we can write the rate law just by looking at the step, which is exactly what we did here. Now I'm going to set my forward rate equal to the reverse rate. So K1 times Br2 equals K minus 1 times Br squared. And we're asked to find an expression relating the concentration of Br to that of Br2. So I want to get Br by itself. To do that, I'm going to divide both sides by K minus 1. So that's going to cancel. And now I have K1 over K minus 1 times Br2 equals Br squared. And I want to get Br by itself. To do so, I'm going to take the square root of both sides. So now I can say Br, which is the intermediate that I'm asked to isolate, equals K1 over K minus 1 times Br2 to the 1/2 power or square root. And that would be our answer. So hopefully this was helpful in practicing those steps where you need to create an expression for the intermediate, where you set the forward rate equal to the reverse rate, write down the rate of the forward reaction, write down the rate of the reverse reaction, and then algebraically solve, or set them equal to each other, and algebraically solve to get the intermediate by itself. We're following, I think it was the 6 steps we wrote down on the previous video lecture to follow this.